And now let's get started with our keynote speaker. Jessica Heim is currently pursuing graduate studies in cultural astronomy through the University of Wales, Trinity, St. David. She recently submitted her dissertation, the final assignment required for receiving her MA degree. In this research, she studied community experiences with dark sky initiatives and dark sky friendly LED streetlight retrofit in rural Idaho. Prior to her graduate studies, she attended the College of St. Benedict, graduating with a double major in environmental studies and music. Jessica is a cultural astronomy editor at the newly launched Journal for Dark Sky Studies and is particularly interested in non-Western and indigenous perspectives on the sky. She enjoys engaging in educational outreach focused on the connections between culture, science, and the night sky. Thank you so much for joining us today, Jessica. Take it away.
Okay, well, thank you so much for coming, everyone. I'm so excited to talk about cultural astronomy and share some of these really interesting things about the night sky with everyone. It's so much fun to learn about the stars, and it's also fascinating to discover how important the stars have been to people throughout history all across the world. So let's begin with answering this question. What is cultural astronomy? When I talk about my research and my graduate studies, that's usually the first question I get is, cultural astronomy, what's that? Well, there's many definitions, but I like this one. Dr. Jarita Holbrook says, cultural astronomy is the study of humans and their relationship to the sky. So in a nutshell, that's basically what cultural astronomy is it's looking at the human element of the sky. And it's not only about the things in the sky, but it's how people engage with them. And so where I am studying through the University of Wales, I live in Minnesota, but it's online, so I can study in Wales. It's the Sophia Center for the Study of Cosmology and Culture. And the program director, Dr. Nicholas Campion, describes the program as, we study the many ways in which human beings endow the cosmos with value and use the sky as a theatrical backdrop to tell stories and create meaning. So examples of the many different things you can study in cultural astronomy would be archaeoastronomy. Archaeoastronomy, like its name sounds, has more to do with archaeological sites. So the most famous of which, I'm sure, is Stonehenge. Another one, this is Pueblo Bonito out in Chaco Canyon, out in New Mexico. And with archaeoastronomy, people are interested in looking at archaeological sites and often how they were aligned with the sun and the moon. So for example, like on the summer solstice, the sun might rise and the light would come through the architecture of such a place in such a way that the light of that morning sun would shine in a particular place. And so that is a little bit about archaeoastronomy. So looking at the sky more broadly, the night sky and a view of the stars has been an integral part of the human experience for millennia. Before the advent of artificial lighting on a broad scale, the night sky was truly dark, with the stars, planets, and Milky Way showing up vividly in contrast against the black background. This star backdrop was experienced as just as much a part of the environment as its terrestrial counterpart. After all, the sky takes up half of one's field of view. Not only were the stars highly visible, but their locations changed in reliable and predictable ways from season to season and from year to year, which rendered them a valuable aid to timekeeping and navigation. People across the world took note of both the assemblages of stars in the sky as well as their apparent motion over time. The patterns people found, both in space and through time, often became deeply integrated into many parts of their culture, and ideas about the stars found their way into all aspects of society, from art to architecture to religion to philosophy. So let's begin by talking about something that many people here are probably familiar with, the Big Dipper, and how we can use it to help us find directions, an important part of navigation. So here's our Big Dipper, these bright stars in the northern part of the sky. And in this image, you can see both the Big Dipper and the Little Dipper. And if you've ever tried to find the Little Dipper, it can be a little tricky, but there's a simple way to find it. You first find the bright stars, the Big Dipper, and these two stars on the edge, we call these the pointer stars. And this distance in the night sky, you take this 4.5 times this direction. So we have 1, 2, 3, oops, I clicked it, 4.5, and there's Polaris, the North Star. And these little stars that are a little dimmer here, here's our little dipper. So once we find Polaris, the pole star, we know that we just go straight down and that's north. And so then, if we know that way's north, we can figure out where the other directions are. But knowing where Polaris is, we can also learn some other things about navigation other than just the direction, north. So to illustrate this, I'm going to show you a few things on Stellarium. This is a free planetarium software anyone can download. If you go to stellarium.org, you can find out how to download it on your computer, iPhone, any sort of device you have. And it's a really fun software to work with. So I'm going to go to Stellarium now. So this is what you'll see if you look in the north in Minnesota in fall. So here's our Big Dipper. We'll just focus on that for now. And Polaris and the Little Dipper. Now, you notice this is above north. But the other thing you notice is there's a certain distance above the horizon it is. And it turns out that the angle that Polaris is above the horizon is exactly the same as what your latitude is on Earth. So this only works in the northern hemisphere. But so in central Minnesota, we're at about 45 degrees north latitude. And so that means that in the sky, Polaris is 45 degrees above the horizon. So 0 would be down here, 45 is halfway up, and right above your head, which is zenith, that's 90 above. So that means that if we travel someplace different on Earth, we will see Polaris in a different place. So let's go on a trip very quickly. You can travel fast with planetarium software. Let's go to about 10 degrees north. So right at the northern part of South America. And look, Polaris is right on the horizon. Now let's travel again. Let's go close to the North Pole, northern Canada. And now we look to the north and we wonder, gee, where'd Polaris go? Well, it's not going to be the same place it is in Minnesota. We have to look way above our head. So if we're up the North Pole, Polaris will be right above our head. So that's one thing that's really neat about using the stars to help us figure out how far north of the equator we are. Another thing that's associated with Polaris is this idea of circumpolar motion. So I'm going to go back to central Minnesota. And I'm going to advance time. And we're going to go through a day. So this is what happens in a day. Only we're speeding it way up. And I turned off the sun so we can still see these. So what you notice is over the course of a day, the stars go around Polaris like this. Now, really, they're not going around Polaris. The Earth is rotating on its axis. And from our viewpoint, standing on the Earth's surface, it looks like these stars are going around. But Polaris, if you were to take an imaginary line from the North Pole and put it outwards into space, it would go right into Polaris. So that's the motionless point. And all these constellations and stars close to it, they go around, they're always visible. Not visible literally in the sense that you can't see them in the daytime, but they're always above the horizon. Now, these ones here are called circumpolar. They circle around Polaris. But as we go further south, we go towards west over here and east over here, notice they are different. They'll change. And so that means that not all the stars are circumpolar. And when we look to the south, we'll see different stars in different seasons. So for many cultures, these circumpolar stars were seen to have special importance because they never set, they never rise. They're always there every night of the year. So for example, in ancient China, The stars in that part of the sky were associated with the emperor and high-ranking court officials. And so oftentimes whatever a culture finds particularly important and central to their ideas is often represented in this part of the sky. But now when you go to a different place on Earth's surface, say let's go back down to the equator again, you actually don't have circumpolar motion anymore, because everything rises and sets at the equator. Nothing's circumpolar because Polaris is on the horizon. So it's a very different perspective. And the exact opposite of that, up at the North Pole, because Polaris is right above our head, everything is circumpolar, and we see the same stars every night of the year. So that's one thing that's important to keep in mind when you're looking at different cultures, is the view is going to be slightly different, and they'll see not only sometimes different constellations, but also they will appear to move in a different way depending on where you are on Earth. So going back to the PowerPoint, one more thing that you can use yourself when you are trying to make connections between the seasons and the stars is the Big Dipper. It's so bright and easy to find, but you might not know where exactly to find it in the north different times of the year. So if you look in the evening in the fall, in Minnesota or any latitude around there, a little ways further north or south is fine too. In the fall, you look for the Big Dipper in the evening. It's going to be on the lower part of the sky here, not that far above the horizon. It will look like a basket or a wagon you're putting your fall harvest in. And then in the wintertime, say you go out in January, a few hours after sunset, it will be here. This looks like the side of a house, and this is your icicle coming off the side of the house because it's cold in the winter. In the springtime, you go out and look for the Big Dipper in the evening. It'll be really high in the sky. You'll have to look up pretty high, and it's upside down. Imagine it's pouring out all the springtime rain. And then in the summertime, it will be kind of this northwest direction. It'll be, the handle will be straight up and down, and pretend this is a blade of grass growing in the summertime. So that's one way you can use the seasons to help you find the stars and to help you with navigation. Now, one other thing to note is if you go out at like 4 in the morning, 3 in the morning, it will be a little different because the Earth keeps rotating. But this is for in the evening when most people will be looking at the stars. So an example of how some different cultures have utilized the seasonalness of the stars would be in the Pleiades, which is not a constellation, but it's a very famous group of stars. This picture was taken with a telescope. You won't see it quite this pretty with your naked eye. It'll be just a little kind of fuzzy blob. Both binoculars, it is very pretty. It's in the constellation Taurus. It's by Orion, the hunter. So you'll see it in the winter. But in the ancient Greek text by Hesiod, Works and Days, he talked all about planting and how to be a good farmer and things like that. And an example of one thing he said was about the Pleiades. He said, when the Pleiades, daughters of Atlas, are rising, begin your harvest and your plowing when they are going to set. 40 nights and days they are hidden and appear again as the year moves round, when first you sharpen your sickle. So he was talking about the 40 days was when the constellation was below the horizon. You wouldn't see it at night. And then the timing of when you would see it, you would time your farming activities accordingly. Another example having to do with calendars, timekeeping, has to do with Sirius, which is a very bright star, brightest star we can see here. And if you know where Orion is, it's not too hard to find it. You go this way from the belt stars, and there it is. It's super bright. This was an extremely important star for the ancient Egyptians. And so they were very interested in the helical rising of Sirius, which is kind of a funny word, but think of Helios, the sun. It has to do, the word helical rising is when you can see a star in the morning before the sun rises. And so the first day that you can see Sirius in the morning before the sun rises up high enough that it bleaches it out with its light, that's the helical rising. And the helical rising in ancient Egypt of Sirius was associated with the flooding of the Nile. And so when they saw Sirius in the morning, they knew that the Nile would be flooding shortly, and that was an extremely important event for ancient Egyptians. They're in a very arid region, and that flooding of the Nile was the way that they were able to have fertile cropland, and have enough food for their population. So what you see in the sky above you will differ based on where you are, what time of the night you are looking, and what time of the year it is. A lot of variables there. So this is what you would see. Imagine you go out in the fall in Minnesota, you're looking towards the northeast, and this is what you'll see. And any other latitude on Earth, you'll have that same view. And if you go a little farther north or south, just be slightly different. And so there's many ways to connect the dots, and different people, different cultures have seen different images. What we often think of in the West as the constellations are the ones from the Greco-Roman tradition, which is based somewhat on Greek, but there's also a lot with Egyptian, Sumerian, Babylonian, all those cultures there had stories that tied into these constellation pictures that we think of today. So these are ones a lot of you are probably familiar with. Here's Ursa Major, the Big Bear, Orion, the Hunter, Perseus rescuing Andromeda, the princess. There's Cassiopeia, the queen, and Cepheus, the king. Ursa Minor, the little bear, a little hard to see, but there it is over there. So here's some of our Western constellations, but you can see this exact same point of the sky from a different perspective. So for example, these are some Ojibwe constellations, exact same part of the sky, but it looks rather different. So here's Polaris. Mung, Loon, is the part of the sky where in the Greek tradition they see a little bear. So it's a totally different way of looking at it. And instead of a bear, this is Ojig, the fisher. Very different animal. And up here, this moose, this would be some of the same stars, not all of them, but some of them, this box right here, are part of the Greek constellation Pegasus. But the Ojibwe, they didn't see a flying horse, they saw a moose. So oftentimes what people saw in the sky differed based on what they saw around them. Not that the Greeks were necessarily seeing flying horses where they lived, but you never know. But there are definitely loons, fishers, and moose in Minnesota. And this image that someone made here, you can check this website out here. This is taking all of these different perspectives. This isn't everybody, but these particular perspectives that they were able to find some data on constellations, and just looking at stars of Orion, these really bright stars, and seeing how people in different cultures group them differently. So here's the western one of Orion here. This is probably pretty familiar. The Ojibwe winter maker is kind of like Orion, but he has much longer arms. And some of these other cultures, it doesn't really look like the Orion that we would typically think of. So one thing to keep in mind when looking at indigenous, First Nation, Native American cultures' views of the sky is there's a cultural context, a cultural protocol that you need to be mindful of. So, for example, in many Native American cultures in this part of the world where it snows in the winter, they will often say that, well, these stories are, in general, that they have in their culture, but also, the star stories. We should only tell these during the winter when the snow is on the ground. And different elders will interpret this differently than others. Some will take it, quite literally. Some will say, well, we shouldn't tell the stories in the summer, but we can kind of talk about the constellation or just kind of give the main points of it or that type of thing. But that's one thing to always be very mindful and respectful of, is that it's a different way of viewing the sky than in like the Greek Western tradition. We tend to think, oh, okay, there's these cool stories and we just tell them however, whenever. But there's many layers of meaning oftentimes associated with indigenous constellations. And so you may have like a superficial surface level of the story, and then there can sometimes be deeper levels of the story that may not be told to all people in all context, maybe only in the context of certain ceremonies. So that's one thing that's different, is just to make sure to be respectful of that element. And another thing is it's very easy, I think, in the Western tradition to think of, oh, the sky, these stories up there that have nothing to do with life on Earth down here. And in many of these traditions, that was very much not how they saw it at all. They saw this sense of reflection of above and below. And what was going on in the sky was very tied to what was going on Earth. They weren't separate, and they were very related. And there's a lot of examples of like the language, daily life, earth and sky are very integrated. Things that we tend to separate often in the Western world. Oh, this is science, this is religion, this is philosophy, where it was more of an integrated life way. They didn't separate it out like that in a lot of these traditions. So one of the initiatives that I've been involved with for quite a while is the Native Skywatchers Indigenous Astronomy Revitalization. So this is led by Professor Annette Lee. She is an astrophysicist, artist, and the director of Native Skywatchers. She's a physics professor at St. Cloud State University. So designed by Annette Lee, the Native Skywatchers initiative seeks to remember and revitalize indigenous star and earth knowledge, promoting the native voice as the lead voice. The overarching goal of Native Skywatchers is to communicate the knowledge that indigenous people traditionally practice a sustainable way of living and sustainable engineering through a living and participatory relationship with the above and the below, sky and earth. And this is a team, and there are many more people. These are just some of the core members that have been involved with this initiative, but Annette has worked with many different tribes, particularly with Dakota, Lakota, Ojibwe, those are her communities, and working with elders in different tribes to talk about their star knowledge, to make sure it's preserved for future generations. And so here's some of the people on the team that she's been working with. And so Annette has been working on this for quite a few years. And one of the things that she has done collaboratively is she has done these really beautiful star maps. So this is the Ojibwe star map that she has done. And so she painted this all. And the background light constellations, those are the ones in the Greek tradition to kind of give you a sense of your bearings so you know where you are. And the brightly colored ones here, those are the Ojibwe constellations. And so she has a map. There's also an associated guidebook. And Carl Galboy and Ron Morton have co-authored the books Talking Rocks and Talking Sky. And most of these resources I mentioned, they're in the cultural astronomy page on the Bell Museum site, so you can look up those there if you're interested in learning more. And so similarly, this is the Dakota, Lakota star map. Different constellations than Ojibwe. And there's a guidebook as well. And this is another map that Annette did in collaboration with Wilfred Buck in Canada. And this is the Innu or Cree constellations in Canada. And they work together to put down some of their constellations in this map. So sometimes people will think of, oh, Native American constellations. What's the Native American constellation for this? Well, there are so many different tribes, and they all have their own traditions. Some overlap. There is some similarity from tribe to tribe, and some are different. And so there's just a lot of complexity and nuances associated with different groups of people. One thing that people sometimes ask when they look at these maps is they'll say, well, the Greeks had all these constellations, and then you see these native maps, and you think, geez, didn't they see more constellations? And part of that is the history associated with Western advancement, the frontier, all of those sorts of things, and the history with the colonialization, settlement of the plains, all of that. So there's a lot of lost knowledge because a lot of this was highly, highly suppressed. A lot of the teachings with trying to force Native Americans into an assimilationist type way of living, the boarding schools. The Indian Religious Freedom Act, saying that Native Americans have a right to practice their own spirituality and traditions, wasn't passed until 1978. And so there's really a very recent history of suppression of this type of thing. So that's one of the major driving forces behind Native Skywatchers initiative, is to revitalize this knowledge, to make sure knowledge is passed down that would otherwise be lost. So just looking briefly at a few of these constellations. So this is Towing, blue or birth spirit one. This is same part of the sky as our Big Dipper in the Western way of looking at it. And one thing about this constellation is that it shows that there's different ways of looking at the same area of sky. So sometimes a given culture can have multiple constellations for the same stars. So for Dakota, Lakota, this can be seen as birth woman, but also this can be seen here, if you look at these 4 stars, as a coffin and 3 mourners. So really this area of the sky is associated with birth and death, with coming in from the star world to be born to live on Earth, and then at the end of life traveling back into the sky to the spirit world. So it's the sense of a doorway between worlds. So looking to the south, our current season of stars is what we see straight overhead and above in the south. And the next season of stars are rising in the east, and the previous season are setting in the west. So if I go out tonight and look at the stars and look south, I'll see different stars than if I go out in, say, July. So where the stars are in the sky, how they're moving, often has a role to play in the importance and teachings about the constellations. So as I mentioned a little bit earlier, in a lot of these traditions around the world, there's this idea of as it is above, it is below, this sense of connection between earth and sky, them not being separate. So one example would be in the spring on Earth, you see the spring stars in the sky. And it's a sense of reflection. It's this mirroring idea. So here's our moose. Remember the moose constellation. In the fall, this constellation is up and above. It's high up. So that means that when that constellation is high in the sky, that means it has a lot of power. And so like when it's rising, before that, it means it's gaining power. After that season is over and it's starting to get closer to the western horizon, it's seen to be losing power. So when the moose is gaining power, that's when the moose go into rut. They're more aggressive. They're a little more scary to be around. And so that's reflected, the story in the sky and what's happening on Earth. Same thing with the winter maker. The winter maker has to do with winter. So when winter maker is rising, it's starting to get colder. Winter maker is gaining power. As winter maker gets lower in the springtime, it's starting to get warmer. Winter maker is losing his icy grip on the world, and spring can return. So if you're interested in learning more about the Ojibwe, Dakota, Lakota teachings about the stars, Annette has a lot of different initiatives going on with her Native Skywatchers. So if you go to nativeskywatchers.com, there's a lot of stuff there. Typically, she would do these in-person workshops, which of course isn't happening now, but she has a number of virtual events happening. There's one tomorrow morning, and that's focusing on Lakota astronomy. And also, just this idea she describes as two-eyed seeing with one eye from the lens of the native traditions and the other eye through like Western science. And so looking at both ways of seeing the world. And Annette is also giving the keynote presentation for the International Dark Sky Association's annual meeting starting on Friday. And the IDA has an annual meeting every year, but this year is the first year it's virtual, so anybody and everybody can join for free. So if you're interested in checking out some of their dark sky programming, you can go to their website and register. I'll be watching Annette's talk. It should be really good. So shifting to a completely different part of the world, this is the southern hemisphere sky. So we've talked a lot about the northern hemisphere, but when we go to the southern hemisphere, it's quite different. So the constellations that we see in Minnesota, like let's say Orion, they're towards the south and they're kind of low on the horizon. Once you get closer to the equator, those stars get higher. And then, as we mentioned before, Polaris gets close to the horizon. Well, if you go far enough south, let's say you go to Australia, you don't see Cassiopeia or the Big Dipper, the Little Dipper, or Polaris. You don't see any of those northern constellations. They're all hiding below the horizon. And you still see some of those like Orion that we see in Minnesota, but they're upside down and they're towards the north. And then when you look to the south, and you're in Australia, you see a whole bunch of stars that we can't see here in the northern hemisphere. And one thing that's different about the southern hemisphere is that, just like the northern hemisphere, they see the Milky Way, but it's much more vivid part of the Milky Way. So it's a much more prominent part of the sky. And the other thing that's quite different, other than just the constellations are in large part different, is you have these little fuzzy blobs in the sky that you cannot see here in Minnesota. It's the large and small Magellanic Clouds. And so they are kind of like our Milky Way. So our Milky Way is the galaxy we live in. It's our home. There's lots and lots of stars and gas and dust all bound together with gravity. And that is the plane of our galaxy is what you're seeing when you see the Milky Way. Most of what you see in the night sky is in the Milky Way, but it's just denser in that thing we call the Milky Way going through the sky. But the large and small Magellanic Clouds are kind of like the Milky Way. They're little dwarf galaxies that are next to our Milky Way. And just like the Milky Way, they're full of stars and gas and dust, but you only can see them from the southern hemisphere. And so, understandably, because the sky looks a little different, you have some different stories and different ways of looking at the sky. And one thing that's particularly different in the southern hemisphere is you have a lot of cultures that see constellations not only by connecting the points of light, like we do in the north, it's like connect the dots, right? But they look at the Milky Way, and it's so complex, the patterns of light and dark, that there's these dark areas where there's dust that the light can't come through in the Milky Way. And these areas are, like you can see here, are quite dark. Now, this is a time exposure, so the sky wouldn't be quite this bright. But so there's areas of the Milky Way galaxy that are darker. So there are many dark constellations made by looking at the dark blobs and seeing that as a constellation against the bright background of the Milky Way. So, for example, looking at South American, Andean region, the Incan constellations, this dark area, this is considered the mama llama. They have llamas there, and we don't. And here is the baby llama. And then in Australia, there's this emu in the sky. Now, one thing to keep in mind, too, just like in North America, there are so many different native cultures. There's not one Native American culture. There are hundreds of different Aboriginal groups, and they have different stories as well. But there is some commonalities, and this idea of an emu in the sky is one that's shared by multiple traditions. And so there is also rock art that shows the emu in the sky on the ground as well. And here is a coin the Australian Mint has done recently to commemorate the emu in the sky. It's pretty cool. And this is a really nice website if you want to learn more about Australian indigenous astronomy, aboriginalastronomy.com.au. And so here's just some examples of what's on their website. You can learn all these different celestial objects, some of the native perspectives on them, ideas for even more books, papers. It's just a great launching site if you want to learn more about that. And this book I really like, Emu Dreaming. It's a nice short little booklet. It's a really good introduction if you know nothing about Aboriginal astronomy. You just want a short introduction. You don't want a long technical academic book. It's just a nice little booklet with nice color pictures, and I think it's a great intro. So now I'm shifting to a totally different direction, looking at light pollution, the topic, I should say, of our theme this week, and looking at how that relates to dark skies and cultural astronomy. So currently, more than 60% of Europeans see the Milky Way. Nearly 80% of people living in North America cannot see the Milky Way. And this is data based on satellite data. So the areas that are black have little to no light pollution. The red areas, they have a lot of light pollution. It's being emitted up into the sky, and they can detect it with satellites. So this is an example of data showing the change in light pollution in the United States. Late 50s, there were some. Middle 1970s increased, 97 quite a bit. These first three are based on actual data that happened 2025. This is a projection based on current trends. So yeah, a little scary looking. Not inevitable, but based on current trends. So with my research for what I'm doing for my graduate degree in cultural astronomy, I was really interested in looking at the example of how communities in the U.S. might work to preserve dark sky places and put in street lighting that works better, that lights what they need on the ground but doesn't blast it up in the sky. So what I did last fall, it was easier to travel last year, is I went to Idaho, and my area of study was the Central Idaho Dark Sky Reserve. It's a beautiful mountainous region. This gives you a sense of the scenery there. And most of my research was done in the little tiny town of Stanley, an old west town out in the mountains. Very small year-round population, but a very big tourist destination in the summer. A lot of their economy is based on tourism. And this was my research aims, which could take an entire hour or two to discuss in full, but I just wanted to put one slide in to give you a sense of what I was looking at, and then I'll just delve into one little aspect of it. So basically what I was interested in doing was looking, one, at the dark sky friendly LED retrofit they did. There's so many LEDs going in now that are really bright white. They have so much blue light. They're really very disastrous as far as light pollution. They produce a lot of glare. And so I wanted to see, okay, here's a place that's putting in LEDs that are actually good for the sky. So I wanted to learn about the lighting and the whole process of that, which is a totally separate topic. But I was also interested in looking at community experiences, what people there thought about dark skies. What was the role of dark skies in their lives? And so that's what I will discuss here. So if I were to kind of pick out a couple themes from my findings, I did interviews, questionnaires, things like that. The dark skies were really seen as integral to quality of life and well-being in Stanley, and the importance of a personal first-hand experience for sparking interest in dark sky conservation seemed to be a major thing. So when I asked people about, well, why is preserving dark skies important to you? These are some of the reasons that I got. They thought, it's a good to the Stanley economy. Astrotourists come in, and that provides another economic draw for the region. People come in and support the local economy. One person said about dark skies, it's essential to maintaining the quality of life that I enjoy. Another said, because it creates an atmosphere of peace and beauty that is seldom experienced otherwise. It's good to have for future generations. And one said, the quality of life in Stanley is related to the quality of the surrounding natural environment. Starry night skies are an integral part of that environment and an essential element of the wilderness experience that I enjoy. For a modern city dweller, it may be difficult to imagine just how important the night sky was to cultures that had access to an unpolluted night sky. However, visiting a place where the night skies are very dark can enable one to more deeply understand the centrality of the night sky in the lives of those who experienced it in this way. When viewed from a place with minimal light pollution, the sky is not merely something interesting to look at. Rather, it is a part of the environment just as real and just as important a part of the lived experience as anything found on the Earth. Being under a truly dark sky is a completely immersive experience. No longer does it seem that we, the observers, are down here and the stars are out there. Instead, it is more of an experience of feeling one is actually in the starfield. Those who have had the opportunity to spend time in places with very dark skies often describe their experiences quite vividly. In previous research, I asked amateur and professional astronomers about their experiences with very dark skies. Responses included, quote, "It just seemed like you could almost touch it," end of quote, and, quote, "It's a completely different world. When you're in a location with a truly dark sky, you feel like you're being sucked into the sky," end of quote. So to conclude, when the night sky is lost to light pollution, we lose a part of ourselves as well. As Nicholas Campion put it, quote, "Light pollution cuts off our heritage, reduces our well-being, and deprives us of contact with a huge part of our natural environment," end of quote. If future generations are to be able to experience and be inspired by the view of a magnificent, starry night sky, then concerted action is necessary. The 19th century American naturalist and transcendentalist thinker Henry David Thoreau once wrote in his journal, quote, "I would not like to think that some demigod had come before me and picked out some of the best of the stars. I wish to know an entire heaven and an entire earth," end of quote. With increased awareness of the effects of light pollution and the value of dark skies, as well as implementation of improved outdoor lighting, there is the opportunity to leave for our descendants a world in which they may know an entire heaven and regain their connection to the stars. So thank you so much for listening. And now we will have time for question and answers.
Well, yes, thank you, Jessica. Oh, that was a really great presentation, getting everyone, including our audience, to kind of think about different ways of seeing the sky throughout all of history. And so we do have a few really good questions. One person asked if you could recommend any general audience books for further reading. And we did share out the resources that you provided. So we are pointing people toward those. Some people weren't quite sure where to find it. If you scroll down a little bit on our Statewide Star Party page, there's a tab for cultural astronomy. And I know I'm looking forward to finding Emu Dreaming. That looks fun. But are there any in particular that really come to mind for you, Jessica?
Well, I guess it depends on what you want to look at. I think I give a pretty good description on there of what exactly the books are all about. The one I think was Ancient Astronomers by Anthony Avini. I believe that's out of print, but I got it used on Amazon, and I really like it just because it has a lot of colored pictures in it, and I think it's very user-friendly. And the other book by Anthony Avini is, again, it's more words. I mean, there are pictures, but, it's a longer book. And the one by Nicholas Campion, that one talks a lot about various religious traditions and their ideas about the stars. So I guess it's kind of specifically what you're interested in. The books that I recommended that I had in the PowerPoint, the Dakota, Lakota, Ojibwe ones, those are really great. They're very short, thin books, but they have a lot of imagery, and it talks about Western ways of looking at things and the native constellations. So I think those are really good as far as local type interest.
All right, thank you. We had someone ask this question. So when ancient communities traveled, how did they explain or interpret the changes in the sky? Like you were talking about, when you go south, we're going to see other things. So is there any record of how these communities explain that?
Well, I'm not sure as far as like really big distances, like say the North Pole to the equator. I mean, if you travel around a fairly small area, it's not going to be huge. But I know, like, for example, in the navigation with Polynesians, they did a very different kind of navigation than we do in the North, because the way the stars rise, like here, they kind of go at an angle, but they go straight up as you get near the equator. And so they had ways of looking at it with, okay, this star is associated kind of with the direction of this island, and it had all to do with the direction of the stars rising and that sort of thing. As far as like the rationale behind why specifically it changed, I'm not quite sure that particular aspect. I know that there were often like when there were constellations that rose that represented a particular type of thing on the ground, it's like, oh, now it's time that we travel to this location or that type of thing. But it's, I guess, a little different topic.
Okay. This is to me, it seems like a little bit more of a deep, speculative conversation or question. So is cultural astronomy more a study of history, and can cultural astronomy be applied to modern day?
Yeah. So I had a bunch of slides I took out that were on the definitions of cultural astronomy and all these different ways of looking at it.
Yeah.
Because I thought I wouldn't want to belabor the point on this. But so there's different ways of looking at it. So the Sophia Center where I studied in the UK, they come at it from like a humanities, social science perspective. So they often look at it through the lens of history, anthropology, archaeology, that type of thing. There are also people who look at it more so from archaeology, more the physics perspectives. For example, like someone I know, Dwayne Hamacher, who works in Australia a lot with Aboriginal communities, he talked a lot about, and a lot of other people as well, about the idea of like decolonization of science, just knowing that we have a cultural context associated with science. It's not entirely value neutral. There are a lot of knowledge systems in different cultures, their way of looking at the sky that is highly relevant. It's because it's easy to think, oh, there's just all these cool stories about these people in the past. And I mean, that's one aspect of it. But I would say that it's highly relevant for today, especially if you talk to people from different cultures. The stories and way of looking at things, and like there's different ethics and moral lessons. It's so in the language, it's so deeply entwined into like who they are, and it's not just this external thing. And there are examples in, like, say, Australia, for example, because that's an extremely old culture. It goes back like cultures, but it's the longest kind of continuous still living culture from tens of thousands of years ago. And they have stories of observation of things, different supernovae and different observations of the sky and things that they know that modern scientists see as well. It's a different way of arriving at that. Now, they're very observation based, but I would say it's highly relevant today as well.
Okay, thanks. We still do have a few more questions, and we're kind of bridging the two different parts of your presentation today. So we'll get to those. So one more, just a quick one. Someone missed where they can find the Ojibwe sky map you showed.
If you go to nativeskywatchers.com, it's on there on how to order it. I think you order it from the planetarium, the American Indian Center at St. Cloud State University. It should be fairly easy to find on there somewhere. There's contact. If you have any trouble, you can contact the person in charge of the site and they can direct you.
Okay, great, thanks. So here's another question. Do you know how religious systems have been impacted by light pollution? So is there any disruption of the relationship between that people and their perspective of the night sky?
Well, one thing that I've seen a lot, both in people I've talked to and like in just different reading I've done, like the study I did of Minnesota amateur and professional astronomers, there were a number of people who mentioned specifically their faith tradition as being an important part of their interest in the night sky. And I would say that just the idea of not being able to see that and experience it directly, you kind of lose a sense of the personal relevance and whatever your views are on different religious ideas, just that sense of connection to something larger than yourself, you really kind of lose that when you have the light pollution. A specific concrete example I would say would be a paper that's in press now that's for the Journal of Dark Sky Studies, Dwayne Hamacher and some colleagues wrote. And his title of his paper was about light pollution as a form of cultural genocide, speaking about how important the stars are to the traditions of the Aboriginal Australians. And they feel like this is like another form of colonization, impacting their culture in a negative way. And he goes into details about like how that is harmful, to these people and their traditions. So I guess that would kind of touch upon that.
Yeah. So in the last couple minutes, actually, I'll ask this. There might be more questions than we can get to. So I'm hoping Jessica might be able to stick around a little bit and answer some directly in the Q&A if we haven't gotten to them. But I did have a couple more that I thought that the whole audience might want to hear. And they're a little bit more on the personal side, not too personal. But Daniel was wondering, what has been your most spectacular or meaningful dark sky moment?
Yeah. I would say as far as meaningful, and and it's probably not the kind of story you want to hear, but I was doing some research down in Arizona, and I was able to have the opportunity to go to an observatory south of Tucson. And the person who was driving me out there, it just seemed like we were driving forever towards the Mexican border. And I was like, oh, we're out in the middle of nowhere. And so we drive up to this observatory late at night, and like they drive up the mountain with only parking lights on. It's quite an experience because they don't want to disrupt the observation. But getting up to the telescopes and then looking down, I feel like I'm totally out in the middle of nowhere. I should see like no light. And Tucson has put in some pretty dark sky friendly lighting and is not that huge of a municipality. And I was just totally shocked to like just see how incredibly close it looked and how it affected the observatories. Because you can think in a hypothetical sense, oh yeah, light pollution affects observatories. And then you see that and you're like, oh my gosh, they aren't kidding. So I guess that would be probably the most memorable experience.
Yeah. All right. Well, then this follows up on that. If you had a magic wand to preserve our dark skies, what would you implement?
Yeah. Well, I had one slide that I took out that had a lot of words on it about some of my key findings with my research, because that was why I did this research, because I'm seeing my sky disappear and I'm like, okay, either I'm just going to be really angry and go up in a puff of smoke, or I'm going to do some concrete research. What are people doing that's successful? I think it's a combination of, having the right type of lights, and then, but in order to do that, you have to have a general awareness of. So I would say, to sum it up very concisely, I think people have to care about it to do something. I mean, it has to be personally relevant to you. So I think, being able to have that connection with dark skies, and what you're missing. Like one analogy I had heard in a book was like, oh, people expecting people to see to care for the night sky when they are living in light pollution is like saying you should care about a forest when you've never seen a tree. So I think being able for people to see some dark skies, experience it, and then just to have more awareness of things you can do, because it's an environmental issue that's so much more easily solvable than any other. I mean, nobody's benefiting from light pollution. I don't think you can totally get rid of all light going into the sky, but if you lit things better, it wouldn't have to be anywhere near that bad. So I guess people need to access the night sky, connect with it, and just more awareness of the issue, and that there's simple solutions of things you can do about it.
All right. Well, thank you so much once again, Jessica. And if I'm just so excited about everything you shared, and I look forward to looking at the resources that are on our website. So everyone else who's watching too, please go ahead and look those up. I really appreciate the time you spent with us tonight, Jessica.
Yeah, I enjoyed it too.
Thank you. So before we move on, I want to take a moment to express our gratitude to our many partners around the state who have worked with us to make this statewide Star Party a success. So thank you to all the organizations around the state who you see mentioned on these slides. They rallied their audiences, their students, and their stakeholders to join us this week. So thank you very much.